In this lesson today, I'm going to teach you how to find the horizontal and oblique asymptotes of a rational function. So in this question here, I'm given three different rational functions, and what we want to do is we want to predict whether the graph has a horizontal or oblique asymptote. And how we're going to do that is we're going to use the previous slide from my previous lesson, which gives you general guidelines of when an oblique or horizontal asymptote occurs. So I'm going to be switching between these two slides here. So let's go back to the question here. We're going to start with question A. And what you want to do first is make sure the rational function is fully factored. So make sure it is fully factored. Okay, so taking a look at the rational function, look at the numerator, there's nothing much you could do there with factoring, and also the denominator, there's nothing else to factor there either. So this rational function is already fully factored. Next, you want to take a look at the degree of the numerator and the denominator. So take a look at the numerator. That term has a degree of 1. So when you're looking at the degree, you're looking at the exponent on the variable. Same with the bottom here. The bottom also has a degree of 1 because this x has a power of 1, which gives it a degree of 1. Now you're going to take a look at what we have here. We have a degree of 1 on the top and also a degree of 1 on the bottom. So these are equal. Now, go back to the previous slide. When the degree of the numerator and the denominator is equal, which case do we have? Well, we are taking a look at this case right here. It's equal. So when this happens, we have a horizontal asymptote at y is equal to a over b, where a is the leading coefficient of f of x, which is the numerator, and b is the leading coefficient of g of x, where g of x is the denominator. So going back here, we want to actually define the horizontal asymptote. We first need to identify the leading coefficient of the top and the bottom. So the top has a leading coefficient of 2. Okay, so you're looking at the number in front of the term with the highest power. So that in this case it's a 2. And on the bottom we have a leading coefficient of 1. Okay, because there's actually a number 1 in front of that x there. So hence we have a horizontal asymptote. So horizontal asymptote at the line y is equal to 2 over 1, which is simply y is equal to 2. So that's where the horizontal asymptote is. To verify this behavior, stick it into your calculator. So you're going to stick the original function into the calculator. So it's brackets 2x over brackets x minus 4. Okay, so once you have that in there, you have to make sure that you have brackets surrounding numerator and your denominator so your calculator does not get confused. So we're going to use a Zoom 6 standard here. And there you go. We have a rational function graph. And notice what happens at y is equal to 2. So 1, 2, right there. We have a horizontal asymptote. That is a horizontal line that the graph approaches, but it's not going to reach it. Okay, so that's part A for you. Now let's take a look at part B. So once again, the first thing you want to do is fully factor, okay? So we might actually be able to factor something out here. So look at the numerator. We have a common term of 2, so we have x minus 5 left. On the bottom, we have a quadratic, so what you want to try here is try to PSA first, okay? So PSA, our sum is going to be -1, our product is -20, and that gives me two numbers at +4 and -5. Okay, so there I have two factors, x plus 4 times x minus 5. Okay, so now you want to look at the top and the bottom. Do we have any common factors? Well, yes, we do. X minus 5 are both common. So therefore, we are working with a rational function that looks like this. Y is equal to 2 over x plus 4. So this is the rational function that we have to take a look at here. So the first thing we're going to look at is the degree of the numerator and the denominator. This 2 is a constant. So that means we have a degree of 0. Constant terms have a degree of 0. Okay? Now at the bottom, it's a different story. That power on that x is 1, so therefore we have a degree of 1. Okay, so if we take a look at the degrees here, 0 is less than 1. So the degree of the numerator is less than the degree of the denominator. So go back to the slide. Which case does it match here? Well, it matches this case right here. F of x, or the degree of the numerator, is less than the degree of the denominator. So what does that mean in terms of our asymptotes? We have a horizontal asymptote at y is equal to 0, which is the x-axis. So that's what's happening with that graph right there. We have a horizontal asymptote at y is equal to 0, which is also the x-axis. Okay, and also to verify that behavior, you can always stick in your calculator. So get rid of whatever you had in there before, and you're going to stick in the original function, not the factored one. Okay, so sticking in the original function, we have 2x minus 10, close your brackets, divided by, okay, x squared minus x minus 20. Okay, so let's try Zoom 6 standard and see what we get here. Yes, we do have a rational function, and notice what happens at the y is equal to 0 line. That graph is not touching the x-axis, so hence we have a horizontal asymptote right at that line. So we have done that correctly. Okay, so finally, the last question here. We want to, first of all, fully factor this rational function, if possible. Okay, so taking a look at the top here, we could most likely factor out a -1. So try factoring out a -1 and see what happens. So -1 over x squared minus 4. Okay, and the bottom, you can't do much with it, but take a look at the top here. Notice the difference of squares. So you could factor a difference of squares, and that's going to become y is equal to x plus 1. Oh, sorry, there's a negative there. So x plus 2 and x minus 2. And that's all going to be over x minus 3. So we fully factored it, but it looks like we don't have anything to cancel out here, so we're just going to leave it like that. Okay, so now we want to take a look at the degree of the top and the bottom. Okay, so if we're taking a look at the degree of the top here, notice that I'm actually going to get rid of the factored form here, because if you want to look at the degree, it's probably a good idea to look at the original function. So there really was no reason to factor there. So get rid of that there. And so we're looking at the degree of the numerator, which is 2. And the degree of the bottom is 1. Okay, so that means the degree of the top is 1 more than the degree of the bottom. So what happens in this case? Well, we are looking at this scenario. Degree of f of x plus 1 is equal to degree of g of x. So it's 1 more. And in this case, we have an oblique asymptote. So go back to the question here. If we want to find the oblique asymptote, so oblique asymptote. Okay. So we have an oblique asymptote. Now I'm going to teach you how do we find that oblique asymptote. Well, to find it, what you actually have to do here is divide. You're going to divide negative x squared plus 4 by x minus 3. So once we divide, you'll see what happens. So I'm going to do a synthetic division, and we're divided by x minus 3, so the number that goes in front is a positive 3. And then our polynomial is negative x squared plus 4, but notice we may need a placeholder here. We are missing the x term, so we have actually negative x squared plus 0x plus 4. So we need a 0 placeholder in there. Okay, so we have coefficients of -1, 0, and positive 4. Bring down the -1, and we have 3 times -1, which is a -3. Add those two values together, we get -3. And 3 times -3 gives me a -9. And I add these two together, I get -5. Okay, so what was the whole point of dividing there? Well, the quotient which is located right there, is going to give you the equation of the oblique asymptote. So the quotient is y is equal to negative x minus 3. And that is the equation of the oblique asymptote. So to find the oblique asymptotes, you actually have to divide. So let's verify this behavior. We're going to stick in the original function. Okay, so we have negative x squared plus 4 divided by x minus 3. Okay, and we'll use the Zoom 6 standard right now. So take a look at the graph here. We have something that looks like that. Okay, so we do have an oblique asymptote, so it's slanted. So to check what it is, plug in the oblique asymptote or the equation of the oblique asymptote, and that's located right there. So plug in that function along with your rational function. So go to y2, you're going to negative x minus 3, and look what happens. Graph. Notice that that is the oblique asymptote. So the graph is approaching this line, but it's not touching it. Okay, so that is how you find the horizontal or oblique asymptotes of a rational function.